Hello everyone, welcome to this channel. In this video, we are going to discuss about the introduction of ADC, A to D converter, and DAC, D to A converter. Here, the A to D converters and D to A converters are most widely used devices for data acquisition. We know that digital computers use only the binary values, zeros and ones. But the signals in the real world or the physical world are analog in nature. The examples for these signals are light, sound, temperature, pressure, velocity, acceleration, humidity, and so on. These real world signals must be converted into digital signals by a circuit called as A to D converter, simply ADC, before these can be manipulated by a digital equipment. This physical quantity or the physical signal is first converted into electrical signal. That electrical signal is either current or voltage, and it is done by using a device called transducer, which is also known as simply a sensor. Now, these sensors produces an output that is either voltage or current, and that is proportional to the input physical quantity or signal. Therefore, we need an A to D converter to translate the analog signal to digital signal or digital numbers so that the microprocessor or microcontroller can read them and process them. A simple example, if you scan a picture with a scanner, then it converts the analog signal to digital, that means the light picture into digital. Simply, if you record your voice on a computer, then also the ADC converts your voice. Here, for any A to D converter, you have to consider some important points. The first one is resolution. Any ADC has a resolution, and that resolution is n-bit resolution. This n can be any number, 8, 10, 12, 16 or 24 bits. In order to get higher resolution, you have to use smaller step size. Then what is meant by step size? It is nothing but the smallest change that can be recognized by your ADC. Now, let us consider the relationship between the step size and the number of bits. Here, n is number of bits, then the number of steps are 2 power n, and the step size is the reference voltage or the voltage by the steps. For example, if n is 8, then number of steps are 2 power 8, 256. Then the step size becomes 5 by 256, which is nothing but 19.53 millivolts. If n is 10 bits, then number of steps are 2 power 10, that is 1024. Then the step size is 5 by 1024, which is nothing but 4.88 millivolts. If n is 12, then number of steps are 2 power 12, which is 4096. Then the step size is 5 by 4096, that is 1.2 millivolts. And if n is 16, then the steps are 2 power 16, that is 65536. Then the step size is 5 by 65536, nothing but 0.076. Here, the 5 is nothing but the reference voltage as the supply voltage used for that ADC. Now, another important factor is nothing but the conversion time. Conversion time, the name itself indicates that it takes the time to convert your analog input to digital output. That means conversion time is defined as the time taken by the ADC to convert your analog signal into digital signal. These ADC chips are either parallel or serial. In parallel ADC, it can manipulate 8 or more number of pins at a time to get the binary output, whereas in serial ADC, we have only one line or one pin to get the binary output. This is nothing but the introduction about A to D converter. In the next video, we will discuss about the ADC chip 0808 0809 chip with 8 analog channels. Thank you.